Okay, in this video we're going to look at the three different types of decimals. We're going to look at terminating decimals, we're going to look at repeating decimals, and we're going to look at non-terminating, non-repeating decimals. Okay, so the first thing we're going to do is let's convert 1/4 to a decimal. We can always convert to a decimal simply by dividing the numerator by the denominator. Okay. So, if we take 1 divided by 4, we get 0.25 or 25 hundredths. Now, that number stops. It doesn't go on and on. It's just 25 hundredths. So, this is called a terminating decimal. Okay? Terminating decimals stop. They could be numbers like 3.2, 59.8765, negative 3.2019. In other words, all of these numbers stop. The decimal parts stop. Okay, let's look at a number like 2/11. And when I take in my calculator and I do 2 divided by 11, or I can divide by longhand, look what happens. I get the number 0.18181818 and so forth. So 18, it's going on and on in a similar fashion. So I could write this as 0.18 repeating. Okay, now my 8 is not repeating, my whole piece is. So this is called a repeating decimal. So a repeating decimal, you can see very easily that the numbers go on and on. They don't stop. But in some instances on the calculator's going to round. Alright, let's try 1/7. Okay, 1 divided by 7 gives me this. Now let's take a look at that. Alright, we've got 0.142857142.9. Now, let's take a look here. This number doesn't appear to be repeating, but let's take a look and see. 142, 142. This number's an 8. This one's a 9. Now, calculator has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places represented there. And it rounds to get the last place. So, this number actually then would be 0.142857. And the whole thing repeats. Now, let me show you a trick to make sure that you've gotten the right thing. Let's see. It's 142,857. Now, I'm going to write 0.142857, 142,857, 142,857. Okay, I repeated that. Well, let me clear that here a minute. 0.142857, 142,857, 142,857. Okay, I repeated my number, the repeating part, until it went to the second line. Now, the reason I did that, I don't want to have to count. I just know that if I go to the next line, I have plenty of places. And then I'm going to hit enter. The calculator will round. Now, the calculator knows it's rounded, so I'm going to change it to a fraction. And remember, to change to a fraction, we're going to do math. Now, if I hit the enter, then I'm going to take fraction. So this is saying, take this answer, change it to a fraction. And then I'm going to hit enter again. Now, look at my fraction, which is exactly what I started out with. 1/7. Okay? Now again, let's look at 1/3. No, let's look at 2/3 because that's rounded. Alright, so 2/3 would be 0.66 all the way across to the next line. So I'll do math, enter, enter, and it's 2/3. Okay, so that's a quick way of checking to see if you got the answer right. Okay, now let's look at 2/13. So we're going to do 2 divided by 13. Now, let's take a look at this number. Alright, we have 0.1538461538. Okay, now 153846, and then here's where it breaks and starts repeating. Okay, so this is what I'm going to double check on. And I would do 0.153846153846. Then math, enter, enter, and that will get you 2/13. Okay, and that's just a quick way of looking at changing fractions into either terminating or repeating decimals. Now, let's take a look at the non-terminating, non-repeating decimals. So let's look at the number pi. Okay, which is represented with the Greek symbol pi. And on my calculator, I have a pi button. And I've lost it and can't see it. There it is. Okay, so here's the pi button. It is right there above the caret. So I'm going to hit, it's in blue, so I'm going to hit second, and then I have pi, and I'm going to hit enter. And when I hit enter, this gives me a rounded number, pi, a number for pi. Now notice, nothing's repeating. 141592654. Now you can go to pi.org, P-I, not P-I-E, pi.org, and you can look at pi, or just do a Google search, pi to 100 places, pi to 1,000 places. You'll not see any sequence of numbers repeating. I mean, it may repeat and you may have a 1-4 somewhere down the list, but a whole series of numbers is not going to repeat. So that means this number is what's called an irrational number, and turns out to be a non-repeating, non-terminating decimal. Okay, what about, let's look at square roots. So let's say the square root of 9 and the square root of 4. We know the square root of 9 is 3. We know the square root of 4 is 2. But what about the square root of 6? Okay, let's use the calculator to see what we get. Alright, the square root of 6 would be second, and then 6. And again, even though you don't have to close it, I always do. Now, look at this. Nothing's repeating. 2.2449489,743. Okay, so again, I call these messy decimals with students. Messy decimals are the kind that don't repeat and don't terminate. And students don't forget that. This is a nice, neat number. It's exact. This one's a nice, neat number. It's exact. This one is not. Okay? It's irrational, and it happens to be a non-repeating, non-terminating decimal. Okay? Now I can put those 3 dots afterwards, which means I don't want a bar over it because nothing repeats. I need these after it because it's not an exact decimal that ends with that 3. It goes on forever and doesn't repeat. So those are non-terminating, non-repeating decimals.